Hi everyone. In this video I am going to explain about 4-bit binary to gray code converter. Code converters are very important to convert one form of data into another form. So that particular concept is known as code converters. Code converters. So code converters, this concept is used to convert one form of data into another form. One form of data into another form. That means one form of code into another code. So what do you mean by code? Here we have a BCD code, XS3 code, binary code, and a gray code. Like that we are having several forms of data to be represented. If any number 2 is given or 10 is given, that particular 10 can be represented in different ways with different coding formats. So that we can convert from one format to another format. That is code converter main purpose. So for that we need to follow a few steps. The first step is, first you need to draw the truth table between the two coding formats. Okay, first one is draw truth table between two code formats. Okay, so suppose if you are in our given concept, what we have taken binary to gray code conversion. So binary to gray code conversion means you need to take binary on the left hand side and gray on the right hand side. So all the binary codes we have to represent on the left hand side, whether it is a 4-bit, 3-bit, or any number of bits that we need to represent on the left hand side. On the right hand side you are going to represent on which you are going to convert, that is binary to gray code. So gray code conversion is there. This particular table you need to draw. Okay, suppose if the binary data and the gray code data consists of 4-bit, then we have to represent that it into ABCD, and gray code is represented like X, Y, W, and Z. Okay, and the second step is you are going to find out the logic circuit for this conversion. Finally, you are going to find out the logic circuit for the conversion. That is the final step. So for that you are going to write the expression for X, Y, W, and Z. So you need to find the expressions. How to find the expressions for the output values? By using K-maps. So use K-map and find the expressions for output variables. Okay, so in this case it is XYZ. In some other case we are having different output variables. So whatever it is, you are going to find out the K-map for X, Y, W, and Z. Okay, this is second step. And the third step is, once you are able to find out the equation, so the next step is to draw the circuit diagram. So draw the logic circuit using output variables, using output and input variables. Okay, these are the main steps you need to adopt when you are going to convert one coding format into another coding format. So first you need to draw the truth table between the input and output. So input and output is nothing but input is from which you are going to convert, output is to which you are going to convert. So this is input coding format and output coding format. And the second step is K-map we need to consider to get the output equations. And the last step is to draw the logic circuit from the expressions. Okay, so now you are going to see how this binary 4-bit data to be converted into gray code. So 4-bit binary to gray code. 4-bit binary to gray code conversion. Okay, so first you need to take the first step is truth table. draw the truth table between these two coding formats. See, these three steps are very important to design any logic circuit. Okay, so please keep these 3 points in mind. So first one is, on the left hand side you are having binary code, on the right side you are having gray code, and here binary code, as the name is binary, just we are representing that it into b3, b2, b1, b0, and gray code we are representing it as g3, g2, g1, g0. Okay, so as it is a 4-bit data, it varies from 4 zeros to 4 ones, 0 to 16. So 4 zeros. I'm first writing all the binary format. See, already normal binary format you know very well how to represent it. And that is nothing but 8421 code. That is nothing but 8421 code. 100011. So 00, sorry, 001, 0100, 0101. 5. Next 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, now how to represent a gray code? Gray code is nothing but a mirror code. Gray code we can also call it as a mirror code, or also known as a unique distance code. Unit distance code. Gray code is the one which we are using in the K map. Okay, every time when I say K map, I use it to say it's a gray code representation. It's a gray code format. So gray code is nothing but a unit distance code. Successive numbers must vary by a difference of only one unit distance. Okay, so for that, it is also known as unit what is that, mirror image code. Mirror image code representation is very easy. First you need to take 0 1 here. First you need to take 0 1 here. After that, take a mirror image of this one, so it becomes 1 0 here. Okay, now append zeros here and append ones here. Next, take mirror image for these two. So it is 1 0, it is 1 1, and next we have 0 1 0 0, 0 1 0 0. Again take append zeros for first 8 and ones for the, sorry, append zeros for first 4, append zeros for the first 4 and append ones for the remaining 4. It is 1, it is 1. Again take mirror image, so 1 0 0, 1 0 1, 1 1 1 1 0, 0 1 0, 0 1 1, 0 1 0, 0 1 1, 0 0 1, and it is 0 0 0. So append zeros for first 8, 0 0 0 0 0 0, 3 3 6 7 8, and the remaining all are ones. So this is the way to write a gray code format. Normally we cannot represent this gray code format. 8421 code we can represent, but this gray code format we cannot represent it because it is quite confusing. So that's why in order to represent, this is the way. It's a mirror image code. That's why take 01 initially and take the mirror image of this 1001, so it becomes 10. After that append zeros for first half and append ones for the second half. Again take mirror image, append zeros for the first half and second half with ones. Again take mirror image, do the same for number of times, because if it is 4 then 16 combinations will come. If it is a different variable count, then we will be having different count, but this procedure is common. Okay, now this is a gray code output and this is the binary code. Now we are going to generate this G3, G2, G1, G0 using this B3, B2, B1, B0. Okay, so for that, what is the second step? You need to go for K-map. So the second step is K-map. K-map purpose is to find the expressions for all G3, G2, G1 and G0. So that's why for G3, for G3. Okay, so it is a 16 combinations are there, 2 power 4. So 4 input variable K-map, 4 variable K-map must be considered. So 4 variables are there. G3, it is started with B3, B2, B1, B0. So B3, B2, B1, B0. So it is the gray code representation 00011110 and 00011110. Okay, your gray code is also known as unit distance code. Check whether you are having unit distance between the two successive codes. If you take first and second bits, first and second numbers, it is 0001. So only one bit is varying from first to second. Again, if you take the second and third, again one bit is varying. Again from here, one bit is varying. Take any two bits, take any two numbers, any two successive numbers, you can observe only one bit variation. Suppose take these two. See, the first one is varying, remain all are common. Okay, take last two. Only last one is varying, remaining all are common. So like that, we will be having only one bit variation, unit distance. Okay. Okay. So represent all these first 8 zeros and 8 onwards. 8 onwards once. So 8 onwards means here. 8 onwards once. So all these 8 ones we can group together. Then B3, it is nothing but B3. So G3 is equal to B3 alone. We don't have any other combination. All 8 ones are combined in a single K map. Okay. Now for G2, again take four variable K map. B3, B2, B1, B0. So check first 4 are zeros, next 4 are ones, next 4 ones, 4 zeros. Okay, 0, 1, 1, 0 like that. So 0, 1, 1, 0, 0, 1, 1, 0. Okay, so 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So you can map only these 4 and these 4 together. So the expression for G2 is equal to, from here it is B3 bar B2, and from the last one B1, sorry, B3 B2 bar, B3 B2 bar. So how can you say this? A bar B plus AB bar, which is an XOR operation between these two. So B3 XOR B2, G2 is equal to B3 XOR B2. Okay, and next G1. For G1, consider again 4 variable K map. B3, B2, B1, B0, 0, 0, 0, 1, 1, 1, and 0, 0, 0, 0, 1, 1, 1, 1, 0. So now here 0, 0, 1, 1, 1, 1, 0, 0. So 0, 2 zeros, 2 ones, 2 ones, 2 zeros. Again 2 zeros, 2 ones. It is 1 0. Okay. 2 zeros, 2 ones, 2 ones, 2 zeros. Okay. So 0, 0, 2 zeros, 2 ones, 2 zeros, 2 ones, next 2 ones, 2 zeros, 2 zeros, 2 ones, 2 ones, 2 zeros. Okay. So how to map this? So these two and these two. So it is a group of 4 ones and it is also a group of 4 ones. Now check what is the expression for G1. G1 is equal to, from this we have B2, and from these here we have B1 bar. B2 B1 bar plus here we have B2 bar and here we have B1. So what is this? It is the XOR operation between B1 and B2. So B2 XOR B1. B2 XOR B1. This is G1 expression. Next, last one for G0. For G0, we are having again a 4 variable K map. B3, B2, B1, B0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay. Now see, go to the G0 column, and in G0 we are having 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0 like that. So it is 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. Okay, so we are having these 4 ones and again these 4 ones. So how can we map these? We can map G0 is equal to B1 bar B0, and the last one is B1 B1 bar. That is equal to, it is an XOR operation between B1 XOR B0. Okay. Now write all 4 equations at one place. G3 B3, G2 XOR between B3 and B2, G1 XOR between B2 and B1, G0 XOR between B1 and G0. Therefore, output variables G3 is equal to B3, G2 is equal to G3 equal to B3, and G2 equal to B3 XOR B2, G1 is equal to B2 XOR B1, G0 is equal to B1 XOR B0. Okay. Now how to design a circuit for this one? The last step, which is a third step, a logic circuit for this one. Logic circuit for this 4-bit binary to gray code converter. Okay, 4-bit binary to gray code converter, which is, see, G3 is B3. So let us take a B3, B2, B1, B0. G3 is taken directly as G3. B3 is directly taken as G3, and G2 is obtained by taking XOR operation between B1 and B2. So it is an XOR gate between B3 and B2. Next, G1 is obtained by taking XOR operation between B2 and B1. And next, XOR between B1 and B0. Okay, this is the logic circuit for the binary 4-bit binary to gray code converter. Thank you.